So this is law of sines. It is used to find angles and sides of oblique triangles. Oblique simply means that it is not a right triangle. Everything we just did on the quiz review, do you know they were all right triangles?
Yeah.
As soon as you get rid of the fact that it's a right triangle, sine, cosine, tangent, bye-bye. That goes out the window. Pythagorean theorem, nope, can't do that either. Those are only for right triangles. So if you don't have a right triangle, you have to do something different, right? In order to use this, you must have 3 pieces of information. I cannot write today. I know. Thanks for giving me a break. 3 pieces of information and at least 1 side. 1 piece of information has to be a side of the triangle. What I mean by that is, if all I gave you were the 3 angles, you'd never be able to figure out what any of the sides are. Does that make sense? Like if all you had were angles, how would you get any of the side? Like you wouldn't know any of the lengths of any of that. So you need at least 3 pieces of information. 1 of them has to be a side. Please listen to the thing I'm going to say next, because what happens is people get overwhelmed and I don't want that to happen. I'm going to go through all the possibilities right now. We're not going to do them all today. Basically, what I'm going to show you right now is an overview of the entire rest of the unit. Do you get what I'm saying? That we're going to cover over several blocks. Okay, so I'm going to show you the overview of all the possibilities. We're not doing them all today. So don't get overwhelmed and be like, we're doing this all today. We're not. Okay. So first, you can have 1 side and 2 angles. And I dare you all to not groan, because what happens every time I say this next thing is that everyone's like, oh, okay. So the 2 patterns for that, when you have 2 angles in one side, would either be angle, angle, side, or angle, side, angle. Good job. Nobody groaned. Those are the 2 we're going to do today. That's what we're going to cover today, is just those 2 patterns. Okay. All right, second option, you can have 2 sides and the non-included angle. If the angle's included, what it means is it's in between the other 2 sides. So when it's not included, it's not in between them. So that pattern would be side, side, angle. We'll do that one next time. That's the one that's the naughty word spelled backwards. Oh, I'll mark it 100% correct. I love when people do that. I think it's hilarious. Yeah, and the other thing, it's just weird how that worked out, like the way our language works, is that's the one that has like the weird like thing to it. So everyone remembers that because it's that. Anyway, we'll do that one next time. There's a whole lesson just for that one pattern. Okay. Third one, you can have 2 sides and the included angle. So that means the angle is in between the 2 sides. What would that pattern be? Yep, side, angle, side. SAS is what I call that one. And then the last one is all 3 sides, which no one ever has any problem determining that pattern. It's side, side, side. Okay. So for these ones, the 2 we're going to do today, and then the naughty word spelled backwards, it's going to be law of sines. For these 2 patterns, SAS and SS, it's going to be law of cosines. Again, I'm not trying to overwhelm you. What I did there is I gave you an overview of the entire rest of the unit. We're going to do these 2 today. We'll do SSA next time, and then we'll do these 2 the class after that. It's going to be all broken up, but that's like, if you wanted it all in one place, that's everything. Okay. So law of sines, go ahead and draw a triangle. I do not draw any of these to scale. Every single one of my triangles will look like that. And that's what I encourage you to do too, because there are other things to worry about in life than trying to make it look accurate. Like, you do not need to get out a protractor and measure the angles. Like, just, did you do the protractor thing in geometry? Remember that thing that you like? Well, I think they were fine. It's just the ones we have are like always sort of broken. Like, I think if they worked, it would be good. But anyway, so we're gonna call this A, B, and C. And the little letters, the baby A, baby B, baby C, all go across from them. I'm going to explain to you where the law of signs comes from. Whenever I'm able to do that, I like to explain to you why it is what it is, because then you'll remember it better. Otherwise, if I just throw a formula at you and say, here, memorize this, that's first of all rude. And secondly, you won't remember it as well. So then what I also want you to do is drop down the height. The reason we drop down the height is because that gives us what kind of an angle. And now we can bring back all of our sine, cosine, tangent, and Pythagorean theorem and all that. So here's what I'd like for you to do. Watch. I want us to look just at this half. Do you see this right triangle here? If A is your point of view, H is the opposite, B is the opposite, and hypotenuse means sine, cosine, or tangent. And hypotenuse. So, hey guys, it's going to be the law of sines, so it's fine, okay? All right, so that gives us sine of A, big A, equals H over little b. What I want us to do is get H by itself. How would you do that? If you want H alone, yep, multiply B over. We're going to leave that for a second. Or if you're ever like making a recipe where you do like half of it, and it's like set that aside and now do something else, and then like at the end you put them together. That's what we're gonna do. Okay. Now I want you to look just at this half of the triangle. You see this? B is now your point of view. H is opposite, A is hypotenuse. Let's try again. That would be, good job. Sine of big B equals H over little a. Opposite over hypotenuse. Again, I want H by itself. You would do that by multiplying over the A. Why did I get H by itself in both of them? Well, if this is H and that's H, then they are equal. So we're going to set these two things equal. And then last step, what I want to do is get all the A's on one side and all the B's on the other side. So watch me point to the algebra is just moving stuff, right? If I divide this sine of A to the other side, and I divide this sine of B to the other side, it's going to give me A over sine of A equals B over sine of B. And that is your law of sines. And it would also equal C over sine of C. It doesn't really matter what you call any of them, but that is your law of sines. And that is why it works. It comes from sine being opposite over hypotenuse. Hi. Now, this isn't going to matter so much for the two patterns that we're doing today, but it will matter in the future. So I try to just coach everybody to find it in the same order every single time. You're going to find the angles first, and then the sides in order from smallest to biggest. And again, it kind of won't matter for the patterns we're doing today, but some of the ones we do later, it will matter. And if you don't find them in order, the calculator is not going to give you the right answer. So if you just do it the same way every time, then it will go well. And then remember, your smallest side is going to be what with your smallest angle? Yeah, like across, like opposite or across from. So the smallest side is across from the smallest angle. The medium side will be across from the medium angle, and the biggest side will be across from the biggest angle. And that's the way you can just kind of check your work, like to make sure it logically makes sense. Like, hey, does this answer make sense? Okay. We're not going to draw the triangles to scale. I'm not going to make you get out a protractor and try to draw them to scale. Just go ahead and draw something with three sides. Just draw a triangle. Oh yeah, sorry. Yeah. Another thing that's not going to matter so much today, but it will in the future, is like the order in which you label everything. Again, I'm just trying to set you up for success later. If you do these problems the same way every single time, you'll just get used to it. You want to start by labeling the bottom left. Again, today it won't matter so much, but it will later. So just do it this way now. So I'm going to put A down here. Will A always go there? No, sometimes it'll be B or C. It depends on which one you were given. Don't get hung up on the letter of the alphabet. All right. So A is 26 degrees. Then go to the bottom right. So always start at the bottom left, then go to the bottom right. I don't care what the letter is, but what's the other one that we have? B. Okay, so it's just whatever one you have is the next one that goes there. So B is 50. That means up top is C. So start with the bottom left, then go to the bottom right, then the top. We don't have that one, so that's fine. And then baby C is 12. Where does that go? Good, it goes across from big C. So 12 is here. We don't have baby A, we don't have baby B. First thing is the pattern. Now today, we're only doing these two. So you kind of have a 50-50 shot. Is it angle, angle, side, or angle, side, angle? Well, is the side in between the two angles or not is the question. So when you look down here, do you see how the side is in between the two angles? This is the thing that I really can't teach. You kind of just have to look at it. I don't have a better explanation than we have this angle, we have this angle. Do you see how the side's in between them? Okay, so angle, side, angle. Next, you make your little scavenger list of what you're missing. You want that, we're finding everything that's missing. You want to do the angles first, then the sides, smallest to biggest. So what angle are we missing? Yeah, big C. That's the first thing we're going to find. We're making our scavenger hunt list. Now we're missing baby A and baby B. You want to do them smallest to biggest. Which one's smaller? Good. Why is A smaller? So cross from a smaller angle. So we'll find baby A next, and then lastly, baby B. Okay, you got your calculator? You all ready? Okay. How would we get C? Because that's the first thing we want. You would add those together, subtract it from 180. Type that in your calculator. I type 180 minus 26 minus 50, but you can add them and then subtract it from 180. It's sort of like however your brain wants to do it. But what do you get? 104. So do you see how the triangle is very much not to scale? A 104-degree angle would be obtuse. It would look like this. But we don't care if it's to scale. Don't redraw the triangle. All right. Now listen to this. So I'm going to say this over and over again. To do law of sines, you need to have a side across from an angle. You need a side across from an angle in order to set it up. Do we have a side across from an angle? Yeah. We have 12. This angle is, yeah, so if you want to write it in your triangle, you can. So here's the setup. 12 over sine of 104. You match them up across from each other. 12 over sine of 104. And this is kind of like the word problems. You set it up and then you type it in your calculator. So all I'm really looking for is the setup. There's no like steps or work or anything. All right, 12 over sine of 104 equals, now which one are we finding next? Little a. Yeah, you want to do them smallest to biggest. So it'll be a over sine of 26. Is everyone okay with the setup? They go across from each other. 12 over sine of 104 equals a over sine of 26. Now you're probably like, how do we type that? I am going to tell you. You're going to cross multiply and divide. So the way you type this is 12 sine of 26, and you have to close that parenthesis. So 12 sine of 26 divided by sine of 104. So it's cross multiply and divide. You do 12 times sine of 26 divided by sine of 104. That's what we're finding. Like when I hit enter here, that's going to be my answer. And I'm just going to sit still for a minute. So practice typing it. Typing it is a skill that you need. Did we get 5.421? Okay, cool. Now, when you set up to find the last one, look it. It's going to start the exact same way as this one because we're still doing the same triangle. 12 over sine of 104. Hey, Miss Cool, it looks like you just recopied it. Sure did. Now, what goes on the other side will be different, though, because we're finding the other one. What's going to go on this side? Yeah, b over sine 50. Go ahead and type that one in. You're going to cross multiply and divide. It'll be 12 sine of 50 divided by, oh, whoops. Divided by sine 104. Now let's make sure those make sense. Make sure they make sense. We got 5, 9, and 12. Are those like close to the, like, if you got 5, 9, and 112, I hope you would be like, something's not right here. And is the smallest one across from the smallest angle, medium one across from the medium angle, biggest one across from the big angle? It's the way you can check your work, okay? Let's try another one. Just draw something with 3 sides. I don't care, just 3 sides. It's not going to be to scale. Good enough. We have other things to worry about. Where did I tell you to start labeling? Bottom left, all right? Now, it doesn't matter if it's A, B, or C, it's whatever one you've got. So what goes down here? Yeah, A is 110. So it's not to scale. 110 would be obtuse, so it would look like that. Then where do I go next to label? Bottom right. I don't care if it's A, B, or C. It's just whatever one you have, which in this case, C would be 25, and that means B goes at the top. Where does the 19 go? Across from A. So 19 goes here. This is little b, this is little c. Now we're going to make our scavenger hunt list. Angles first, then sides, smallest to biggest. So what are we going to find first? Big B. And then we're missing these two, but you want to do them smallest to biggest. C is probably the smallest because it's across from 25, but actually we could find angle. Let's find angle B and see which one definitely is smaller. Find angle B. These should all add up to 180. So do 180 minus the other two. What do you get for B? Yeah, 45. So yeah, actually, which one of these is smaller? Yeah, C is the smaller one and then B. Oh, and I forgot to ask you what the pattern is. And the reason I forgot is because we're only covering the first two today. So it almost like doesn't really matter so much, but you do need to be able to figure out the pattern. What is the pattern for this one? It's angle, angle, side. Hey, Miss Cole, what if I write SAA? 100% full credit, it means the exact same thing. Do you get what I'm saying? Like if you wrote SAA. What's that? Oh, well, SAA is fine. But do you see how these are different? Like with S is in between them, that's different. But I don't care what order you write them in. Okay, you need a side across from an angle. Do we have a side across from an angle? Yes, it would be 19 over sine of 110. What goes on the other side? C over sine 25. Go ahead and type it in. Cross multiply and divide. It'll be 19 sine 25 divided by sine 110. Do you need me to look at your calculator? I didn't hear any complaining, so I'm going to assume we're okay. For angle, side, angle, the side has to be in between the two angles. And for angle, angle, side, the side is not in between the two angles. So here, watch me point to it. For this one, we had these two angles. Do you see how the side is in between them? For this one, we have these two angles. The side is not in between them. So that's the only difference. How does this last one get set up? 19 over sine of 110. It starts the exact same way. And then just what's on this side changes. B over sine of, what was B? Oh, we found that, 45. Type that one in. You'll have your answer. Did anyone get 14 point some stuff? 297, okay. At this point is usually when everybody starts to stare at me and go, hey, this is actually pretty easy. Like, this isn't too bad. So here's what I usually say to everybody. And I'm going to obviously fill all these out. If you guys try number 3 with your group and it goes well, I won't make us do 4 and 5. Okay? Because they're all kind of the same. But listen, draw the picture, state the pattern, make your little scavenger hunt list, and then help each other with the calculator, and then I'll go over it. So if you're still typing, that's okay, but I just want to make sure we all got it drawn the same. So did you start with the bottom left? And it doesn't matter A, B, C, don't get hung up on the letter, but it's just whatever one you have. So we put 50 here, 72 here. Okay, what pattern did you say it was? Good, do you see how the side is in between the two angles? Okay, scavenger hunt list. What do we find first? Big C, the angle. All right, and then little a, baby a, and then little b. Okay, C is easy. They just all need to add up to 180. What did you get for C? I'm typing it now, but 58, I agree. Now to set it up, you need a side across from an angle. So do we have that? Yes. Let me put the 58 in the triangle here. It would be 12 over sine of 58. That's how it's going to be. Actually, that's how it's going to be set up for both of them. So I'm just going to go ahead and write it twice. Now we want to find A next. So what goes on this side for our setup? Yeah, A over sine 50. And I'm going to type that in. It will be 12 sine of 50. You're going to cross multiply divided by sine 50. What'd you get before I hit enter? 10.839. Does that make sense? Yeah, the other side was 12, so it's in the ballpark, you know. All right, and then for the last one, it would be B over sine 72. Let me show you a little calculator trick for this as well. Again, I'm just trying to save you work. Watch. When you look at these two setups, what's literally the only difference? Instead of 50, it's 72. Watch. If I just go up, I just hit the up button and bring this back. If I just go and change the 50 to a 72 and hit enter, like I don't have to type the whole thing again. Did you guys see how I did that? You just hit the up button, go and bring it back, and then you can just change the one little thing so you don't have to type the whole thing all over again. Anyway, 13.457. All right, so this last thing we're going to look at are our angle formulas. There's 2 of them. And before you're like, oh my gosh, all these formulas, just a brief pep talk. I've been doing this a lot of years. There are a lot of formulas in this unit, but I don't know how to tell you. Every year it just goes fine. Every year we just go over them and you practice them enough. Like, you know how you all know Pythagorean theorem at this point, a squared plus b squared equals c squared. You don't really have to think about it. It's just, you know it. We're going to do these enough that you're going to get it. Like, so don't be overwhelmed is all I'm saying. Now, I do like to give you an explanation when I'm able to. I'm not always able to. There's 2 formulas here. One of them, I can do an explanation. So humor me. Draw a triangle. Thank you. We're going to call it ABC. And so put your like baby letters across from the capital letters. So again, there's going to be 2 formulas. One of them I can do an explanation for. One of them I am going to just throw you that formula and tell you good luck. You can Google the proof if you want. I kind of recommend against it. I think it's pretty complicated. So what we're going to do is drop down the height. Again, if you're like, hey, didn't we draw this on the other side of the paper? Yep, it's the same thing. The reason I bring this up is, does anyone remember the area formula for a triangle? It is 1/2 base times height. Good, I'll get you your sheet in just a second. All right, guys, that went okay, but let's focus. It's 1/2 base times height. What is our base of this triangle? What do we have it labeled as? C is the base, and then H is the height. So now I need like a formula for what the height is, and we're going to do the same thing we did on the other side of the paper. Try to just look at this right triangle. Sine of A equals, if I look at just this right triangle, sine of A equals H over B. And if you get H by itself, how would you get H by itself is actually how I should say it. Multiply the B over. Oops. So B sine of A equals H, equals your height. So if you take this and substitute it in for the height, that will give you your formula. It's area equals, and actually I'm going to write the word area because capital A, like, do you see why like capital A could get confused for like the angle A? So its area equals, it would be 1/2 C times B sine of A. You can write C times B. I'm going to write B times C just because I need it to be alphabetical. That's like a my problem kind of thing. So 1/2 BC sine of A. Now listen. What if you had different information? And what I mean is, what if I twisted the triangle? Watch me write this out. Another version of this would be 1/2 AB sine of C. Do you see what? No, look, let it sink in. Do you see what I did there? Because there's a third version. Area equals 1/2, like jumble them the other way. Good. AC sine of B. Pep talk. You do not want to think of those formulas as 3 separate things. They're all the same. Do you get what I'm saying there? They're all the same. You just jumbled the letters. It just depends on what you were given. Okay. So we're right here, but I'm recording this and you'll be able to watch it later. Okay. Now here's the other formula. And I don't have a proof for this one. I'm going to just tell it to you and you're going to have to go with it. This one is called Heron's formula. Everything in math either like is what it sounds like, or it's named after the person that came up with it. I always say I'm going to come up with like the Cole theorem or something, but it's never going to happen. So. Heron's formula. This is for if all you have are sides, if you don't have any angles. So that you get this S value. I don't know why it's S. I wish it was any other letter than S because S tends to look like a 5. It's 1/2. It looks like a G. I'm sorry. I'll make it a better S. I was trying to not make it look like a 5, but there we go. S, yeah, I know. Like, yeah, sorry. Well, 1/2, and then you add the 3 sides together. So you add them together, divide it in half. That gives you this magical S value. And then the area of your triangle, you're going to draw a gigantic square root, but you're not going to panic about it because you get a, so don't worry about it at all. You're just going to type it in. It is S times S minus A, S minus B, S minus C. And I actually think that's really cool because how did he come up with that? Like, and that gives you the area of the triangle. That's neat. That's so neat. You can disagree, but that's cool. Like, that'll give you the area. How did he come up with that? Well, there is a proof to it. You can Google it if you want, but I don't know it. I think it's pretty complicated. All right, so look at this. You want to look at what you have. And my throat is really bothering me, so if you could make it so I don't have to talk over you, that'd be really cool. You want to look at what you're given. Do you see how we have little b and little c? And then angle A. So which version, let's call this the first one, the second one, and the third one. Which version of this, they're all the same thing really, but which version of it are we going to use? The first one. So our area is going to be 1/2 BC sine of A. So that'll be 1/2 times 10 times 12 times sine of 22 degrees. And you will literally just put that in your calculator. Well, you do have to know the formula. Anyone feeling brave want to share? It is. Now, I don't do units with these, but just for the sake of the conversation, say the sides of the triangle were in feet. Your area would be feet squared. Say it was meters, your area would be meters squared because it's 2-dimensional. All right, look at number 8. I'm going to come down here. We'll do that one last. Do you see how all you have are sides? That's the Heron's formula. You're going to find this S value. It's 1/2, and then you just add them all together. And you're just going to put that in the calculator. I got 26.5. Okay. So that's like the first step. And then you're going to draw an enormous square root. Hold on, do I need to look at your calculator? All right, so underneath that gigantic square root, you're going to put that 26.5 that you just found. And then if you want to draw like 3 more blank parentheses, what goes in the next one would be 26.5 minus 12. What would that give us? You subtract those. Be 14.5. And then in the next one, it would be 26.5 minus 16, which would be 10.5. And then in the last one, it would be 26.5 minus 25, which would be 1.5. And now you're going to put that whole thing into the calculator and it'll give you your answer. Which again, that's the area of the triangle. That's cool. That's so cool that that works. Yes, you do. But again, I don't know how to explain it, but every year it just ends up being fine. Like we're just going to do it enough that it'll be okay. Don't worry. Exactly. Play that song. I got 77.794. Bless you. Bless you. All right, last one. Now the idea is you want to find the area, but here's the problem. For this formula, you would need all 3 sides. Do we have all 3 sides? No. Okay, so definitely not that one. For this one, you need at least 2 sides. And we don't have 2 sides. So we're going to have to draw a picture and find another side. Where should I start labeling? Bottom left. That'll be 55. We will end up finding the other angle as well, but that won't really help us too much. What we need is another side. C is up at the top. Little c is 9. So I heard you say in the pattern over here, what pattern have we got? Angle, side, angle. Now, in order to set up the law of sines, you need a side across from an angle. This is the only side we have, so I need this angle. Subtract them from 180, and that'll give you what the other one is. They should always add up to 180. 57. So to set up your law of sines, it'll be 9 over sine of 57 equals, now we want to do them smallest to biggest. We only really need one of them. Would we find A or would we find B? We would find A. This does kind of bother me because A's tend to look like 9s. So like this is the 9. Let me make that a lot taller. All right, it's going to be A, try to make that look very A-ish, over sine 55. Well, you know, 9s look like A's. I'm sorry. Like it's just, you don't? Oh, okay, there you go. Oh, because you wrote I don't know. Okay, well, I'm really sorry. You had to deal with that. All right, so how do you type this? Good. 9 sine 55 divided by sine 57. Listen, don't clear that out. Leave it sitting there, or you can store it if you want to store it, but I'm going to show you how to do it so you don't have to store it. Okay. So we got A is this 8.790. Now let's think about which version of this we want to use. Look, we have A, little a, and what other side do we have? Little c. So do we want version 1, version 2, or version 3? Do you see how the third one has A and C, the little ones? Okay, here's what you're going to type. You have this in your calculator already. That A, do you see that there? Just hit times, and I want to multiply that by 1/2. And then I want to times that by C, which is 9. And then I want to times that by sine of B, which is, what's B? 68. So if you already have it sitting there, just multiply it by the other stuff and you won't have to store it. So again, I took that, I multiplied it by 1/2, and then times C, which was 9, and then times sine of B, which was 68. So 36.677.